Hello, this is Carlos from Star Pictures Miami. Good evening and happy St. Patty's Day. We are live with the online star party tonight from Miami. We've got uh, we've got a couple things to talk about. We were able to capture the lunar eclipse, and that was very exciting. That was on Friday morning, early Friday morning, and that was really something special. That was really, you know, definitely one of the highlights of my astronomy hobby here in Miami and anywhere. I've attended solar eclipses before, but a lunar eclipse like that on such a clear night was very, very special. And tonight, I hope to share with you some insights on how I was able to capture that. With what cameras I used, what equipment I used, how I did it, and show you some actual techniques that I used to capture the lunar eclipse. And right now, we're checking to see if we've got anybody online right now. Let's see here. All right, we mute that. There, we're muting that. Oh, let me go. And okay, I'm going to share my screen. Let's see. We're going to go there. And there we are. We are now live with my desktop, and I've got the Seestar telescope ready here to start imaging some targets I've got in mind for tonight, the 17th. It's St. Patty's Day, 2025. And I've got a Seestar Smart Telescope set up here in Miami. It's the same telescope that I used to capture the lunar eclipse early Friday morning. And we're going to be also logging into my remote telescope in Texas with the uh, Starfront remote observatories. We've got uh, a second telescope set up in Brady, Texas, in the middle of Texas, at this very cool place called Starfront Remote Observatories. And I have a second telescope there that I can log into and access it remotely, and it really uh, gives me a lot of advantages that I don't have, from here from Miami. In fact, we're looking at the desktop of the computer right now in Texas. So I'll open up the Seestar. That's the Seestar for Texas, and then this is the Seestar for Miami. They look identical because it's the same exact telescope, same manufacturer, same model, two different units, one in Texas, one in Miami. And I'll be able to log into both of them. Just waiting for it to get a little bit darker here in Miami. And but I wanted to talk about the eclipse. Wanted to share with everyone, some images that I was able to capture with the eclipse. Just made a post on the website today. This post at starpicturesmiami.com. Total lunar eclipse, March 14th, 2025. I was able to put together a post with some information, because a lot of people have been asking me, how did you get these pictures? What was your technique? What software did you use, and things like that. So I don't want to dive too deeply into it because it's a little technical, but I did use the Seestar Smart Telescope, which is a telescope that I can control either from my iPhone or from my laptop, or if it's in another location via a remote desktop program like Google Remote Desktop or AnyDesk or Team Viewer, or one of these things like that. But yeah, but the eclipse on Friday morning, which really started at around midnight, uh, was captured all here from Miami. As it turns out, that night I had planned to use the telescope in Texas, but it was very cloudy and windy in Texas, and we were only able to use the telescope here in Miami, which is fine. We got great images. We are very fortunate that it was clear that night. It was very clear. So that's something that I really am very, very grateful for. But here I share the video of the eclipse. This is a 4.5 hour time lapse that was compressed down into 44 seconds. So I was able to download the video from the Seestar, bring it into iMovie on the Mac, and then increase the speed by 20 times. So to speed it up. So I mean, a lot of people are not going to sit and watch a four and a half on a 4.5 hour video of the eclipse. It's like watching paint dry. But if I sped it up. So this video here is, I'm going to open this up here, and this is the time lapse right here. Enjoy. I'll be right back. And tell your friends I need some people in there. All right, I'm back. So that is the eclipse. It's played a couple of times. That's 4.5 hours. I was up actually since 11. I started the YouTube live at 11 p.m. and ran the Seestar all the way from midnight, when actually a little bit after midnight, till about 4 o'clock, a little after 4. So it was a good solid 4 hours of video. And I set the Seestar, which is this telescope right here. That's the Seestar telescope that I use to capture that time lapse video of the solar eclipse that you just watched. This is the Seestar S50 smart telescope, and it's my new favorite toy. I've had it actually for a little over a year now, and it has been phenomenal. What a great product this is. It takes still pictures, time lapse, video, has a whole suite of software there for editing right on the telescope itself. And I can actually pull down the files directly to my iPhone, to my laptop, via the Bluetooth. Extremely easy to use. Just, if you can handle an iPhone, you can handle this thing here. And it's a wonderful thing. I also had my traditional visual telescope, this orange telescope. This is the Celestron 8SC visual telescope. And that one I've had for a couple years. That's a great scope. That's for looking through the eyepiece and looking at a target. It doesn't have a camera built into it, but it does have several great features that allow me to visually observe an object, like the moon. The moon comes in like really very, very detailed with this telescope. And I can point it at star clusters and nebulas and things like that. And I can see a lot of things in the night sky with this telescope. It's beautiful. It's very, very clear. I got some great images by putting the iPhone right on the eyepiece. So there's the eyepiece of the of my visual telescope, and I have this adapter that will allow me to put the eyepiece. The iPhone right on the eyepiece, so I can put the lens of the iPhone right over the glass of the eyepiece, and then take pictures. And I'll show you some of those pictures in a little bit. Then here I was running these two laptops. These are Apple laptops that I have. This is my trusty MacBook Pro, and then I have a MacBook Air, and we're both imaging the moon at night. And I download the video, was able to do some post processing on the time lapse and some of the pictures on here. But I'll show you some of the pictures that I was able to capture with um, the iPhone on the eyepiece. This is one of them right there. This is just a phenomenal picture. This is like no editing. This is straight out of the iPhone. The moon almost looks orange. You know, that's when it was red. But the Celestron telescope, the visual telescope, really has a very large mirror on it and is able to capture a lot of detail. I mean, I can zoom in here and see, you can see the craters just like you would have see it on a full moon. And that is an image that came straight out of the iPhone, with the iPhone sitting on the eyepiece. Here's a slightly bigger picture, um, and you could see the craters. You know, that you would normally see. There's Tycho right there, where I'm putting the mouse there. That's what my favorite crater on the moon there. And then you know, this other one over here. I just like the way that light blue against the background. That's the kind of the outline of the eyepiece, that light blue area right there, and the moon was right in the middle. But yeah, I used my iPhone 15 Pro Max on the Celestron. The Celestron is a has an 8-inch aperture on the front that lets in quite a bit of light, and it allows me to actually get a lot of light. You need a lot of light to capture a lot of images and to see a lot of things in the night sky. The moon, not so much, because the moon generates tons and tons of light. We have so much light coming from the moon. I call it the floodlight in the night sky, especially when it's a full moon. Right now, the moon is about 90%, so it's losing its luminosity right now, and in the coming days it'll dip below 50%, down to 40%, 30%, and then we'll have a new moon in about 8 or 9 days. Then the cycle begins all over again, and the new moon is the favorite time for astronomers and astrophotographers, because we don't have that very bright floodlight in the night sky, which is the full moon. The full moon is beautiful and everything, but when we're trying to take pictures or even observe different things in the night sky, like nebulas, galaxies, and things, with our visual telescope or even with our digital telescope, the light from the moon really does disturb the viewing, to the point where you can't make out the details that you would normally be able to see on a very dim night. A new moon night is when the moon is new and there is no light on the moon. So when it's a new moon, you could go outside and try to look for the moon. It's there, but it has no light on it. So you can try to visually find it, or maybe have an app like Skyview, which I have on my phone, and just point it up and try to find the moon, and then your iPhone will point right at the moon. But that's the best time for astrophotography and for visual observing, when it's a new moon. You know, I actually say up to 30%. So if the moon is 30% lit up, that's still good. So we have about a good week or so of observing time every month to look at the night sky. And hopefully during that new moon time, that week, where it's the premium time to view the objects in the night sky, because the moon is very dim, that we have good weather. So we have to, hope for good weather, hope that the clouds cooperate and they disappear. We don't like clouds. Astronomers' worst enemy are clouds. Second, rain, things like that. So if we have clouds, we cannot observe the night sky. Everything is blocked. So that's the overview here of the lunar eclipse that we had just this past Friday, and we'll look at that one more time. This is the time lapse. 4.5 hours into 43 seconds. There we see it. The shadow is coming upon the moon there. It's going to cover the whole moon, and then it's going to turn red. Boom, there it is. It's like a burgundy red, and that's caused by the shadow of the Earth. At this moment, the cause of the eclipse is that the Earth was directly between the moon and the sun. So we had the sun behind us, we're in the middle, and then the moon is directly lined up between the sun and the moon. So we have all these things going on. It was a perfect alignment. I don't know if you guys caught on the news that there is Firefly, the company that successfully landed uh, a craft on the surface of the moon about 10 days ago or so, sent back. This is the first time. This is an amazing picture. I really encourage you to look it up. A picture from the moon looking at the Earth. So we actually got an eclipse, but it wasn't the moon causing the eclipse, it was our Earth. So the lander had a camera, they pointed it at Earth at that moment, and then it was looking back. So as we were looking towards the moon and observing the eclipse, this lander with its camera on the surface of the moon was looking back at Earth and the sun behind it. And let me see if I can find that, because that is a spectacular view. Let's see. So that's called the Blue Ghost eclipse image. Okay, so here is the picture. This is the picture of the Earth covering the sun. So this is what's called the diamond ring effect. When I attended my wife and I, we attended the eclipse in April 8th of 2024. It was a total solar eclipse. We were in Evansville, Indiana. We witnessed this, but in that case, it was the moon covering up the sun. This picture that we're looking at on the screen is taken from the lunar lander, the Blue Ghost, um, from the moon, on the surface of the moon, pointing a camera at Earth, and that black area is Earth there, and then the outer edge with the diamond ring is the sun. So it's the first time an image has ever been captured of the Earth causing an eclipse on the sun instead of the moon, which is pretty amazing. The way that lined up, they did that launch. They had a successful touchdown. It landed upright on the surface of the moon. They started, sending back pictures and video and everything, and then with the good fortune that they had landed successfully, they were able to point the camera at the Earth during this alignment between the moon, the Earth, and the sun, and to capture this eclipse in this diamond ring was something special. So let's go now, and let's outside. It's pretty dark right now. Yep, I'm looking outside. It looks dark. Okay, so this is the dashboard of the Seestar here in Miami. And let's take a look at what we can observe tonight. We're looking at the dashboard here, the Seestar. We've got in the night sky thousands of targets, millions, actually, millions of targets. This device here can actually look at about 10,000 different targets in the night sky. Nebulas, galaxies, star clusters, globular star clusters, planets and things like that. Though it doesn't really do a good job with the planets, it really does a great job with some dimmer objects. So let's have it look at, for example, let's have it look at the Pleiades star cluster. So M45, that's the Pleiades star cluster. We may have, and I am guilty of this, identifying it as the Little Dipper, because it does look like the Little Dipper. So we're going to go here. I'm going to select M45 there. Actually, let's go to the Sky Atlas, and we're going to go over here. We're going to This is interesting here. So this is a feature of the telescope. It's looking at the night sky, and then I can look up here the target. M45 is the Pleiades Seven Sisters star cluster. So we go M45. There it is, Pleiades. It's an open cluster. It's at about 50 degrees right now. I'll tell it to go to there. So there is an image. This is not a capture yet. It will be in a minute. This is an image of the Seven Sister star cluster. I'm going to draw a little box around it so you can see it here. So there we are. This is the Seven Sisters star cluster. And you can tell it looks like the Little Dipper because you've got this handle here and then the main pot. And it's like a little pot. Imagine like a little pot of that you would put on the stovetop, or a little cup with a long handle that you would like maybe scoop water out of a barrel or something like that. That's what this is. They call it the Little Dipper. You dip it in the water, so it's like a little cup with a little handle on there. So we're gonna point the telescope at it right now. I'm gonna tell it to go to. So right now, I'm gonna zoom in, and you can see the red box here right over Uranus is where the target is. Now you'll start to see a blue box here comes from the bottom. That is the telescope lens moving towards the target right there, which is the Seven Sister, the Pleiades star cluster. So there we go. Okay, now it's on the star cluster itself. There, and it's really homing into really refining the position of the lens right over it. And I think in a moment it's going to start imaging. So what the Seestar is doing, it's looking at this target, it's taking some calibrations, it's really trying to tighten up the view right now. So it's doing what's called a horizontal calibration at this moment. It's looking at the horizon, it's looking at some stars, and then it's orientating itself by the stars that it sees. It doesn't use GPS, it uses the stars in the night sky, much like sailors did, hundreds of years ago, and even to this day, navigate the seas. They look up at the night sky. They know what time of year it is and where the constellations are and where the stars are, and they would guide themselves by that. The Seestar is doing the exact same thing. It's looking up at the stars and saying, "Okay, I know this star over here is Sirius. I know this star is Betelgeuse. I know this star is Rigel, and I know the distance between those three stars." And it does a calculation. It goes, "Okay, now I know where I am based on those three stars. I can go anywhere in the night sky from that 3-point orientation." Now it's preparing to take the first image. The camera is taking a series of what are called darks and um, flats. So it's kind of like, how would I say, the sensor, the camera sensor, the piece of equipment that is actually capturing the image. It's prepping the sensor for this capture, and it's going to in a moment you'll be able to start seeing the first 10-second exposure. It's 60% done with the image enhancing, and it's working there. If you're joining us now, thank you for joining us online, our online star party. We're going to be doing more of these in the future. This is a new technology that I'm hoping to use to bring the night sky to you at home. You can watch it from your iPhone, from your laptop, from your iPad, anywhere you are in the world. It's a beautiful thing. So right now it's auto-focusing. It's doing some more calibrations. It only does this on the first image of the night. If I go to another target after the Pleiades, it will have already taken these steps. It'll be much faster. But on the first image of the night, it does all these calibrations to make sure that the focus is very, very sharp. So in a moment, we should be able to see one of the first images. Let's see, about to perform auto enhancing. Okay, now we're starting to see some stars here, and it's still doing some movement, so they look like uh, they shouldn't look. They look like little lines. They should be perfectly round. Then boom, there's the first image right there. So there are the seven stars there. We've got one, two, three, four, five, six, and seven. These are the seven sisters or the seven stars of the Pleiades star cluster. So right now it's taking an image in what's called a mosaic mode. It's taking different images or panels of that area because it's quite a large target, and in the sensor of the camera can't capture it all in one view. So it will take a picture of one section, then it'll move over, take another picture of another section, move over, take another picture, and then it will stitch those panels or those individual sections of the target together. And see, they're just added to the right. You see, it built out a little bit to the right. It will stitch them together and put them together so that it'll make one beautiful, complete image of the Pleiades star cluster on there. And, this takes about maybe 15-20 minutes for it to start coming together. But you can, I'll zoom in a little bit there. You can see these stars. Now, beautiful thing about these stars is that these stars are very, very um, bright, and they are what are called um, hot blue stars. What does that mean? They have a different color. They actually do look blue. If I've seen them in my visual telescope, and they are very bright. But when you look at it closely, they do shine like a blue, a very bright blue. When stars are blue, that means they're very, very hot. They are they're at temperatures that exceed the temperature of our sun. So these individual stars are basically suns in the night sky. These are stars that form this open star cluster, the Pleiades, and each one of these stars is a hot blue star. So their their heat is very, very high. These are also very, very large stars, many times larger than our sun. So our sun is a star. This is a quick rundown on the sun. The sun, when you go outside and you feel the heat of the sun on your skin, and you see the light and everything, that is being generated by a star, which we call the sun. The star that illuminates our night sky, that makes photosynthesis possible here on Earth, so that plants grow and we can grow food and crops and feed animals and feed ourselves and everything like that, is all made possible by a star, which is our sun. And in the scope of stars, our sun is not too far from us that we're going to freeze to death, though it does get very cold here on Earth, but not too close that it's going to burn everything on our Earth, or make it very uninhabitable. We're in that Goldilocks zone from the distance to the sun, and that is something that is unique. We only have one sun, that happens to be close to us. So it's in our universe. It's the center of our universe. Other stars, these stars are um, hundreds of light years away from us. So we cannot. There's no way for us to travel to these stars that are such incredibly large distances away from us. 1 light year. I don't mean to be throwing around a lot of numbers, but just so you can wrap your head around this, 1 light year is 9.6 trillion, not million, not billion, trillion miles. So 1 light year is 9.6 trillion miles. Okay. Um, for us to be able to travel that far, the problem is we don't have an energy source for in a rocket or a spaceship to go that far. We have to refuel. There's no energy source that we have to take us that far. And it would take, if we were traveling at the speed of light, it would take us a year to reach 1 light year. So these stars are hundreds of light years away. So there is no way that we're ever going to reach any of these stars. But our sun, which is a star, is pretty close to us. So I mean, we've got satellites going around the sun right now. Mercury is the first planet in our solar system that's closest to the sun. That is, pretty reasonable distance. If we could land on the surface of the sun, um, we could make it. We could send a rocket and a spaceship or a lander to do that. But of course, it would burn up, immediately. The sun is very hot. So these stars are hot blue stars. They're young stars. Um, they're probably in the neighborhood of between 2 to 3 million years old, um, which is very young in the life of a star. It's like a little baby, like a recently born baby. These stars will live for tens of millions of years, and they will slowly move away. Stars do move, but very, very in the relative to what we're used to as far as speed, they move, slowly in the night sky, and they will maybe become farther away from each other, or they could be moving closer to each other. But this is the Pleiades star cluster. This is M45. It's a beautiful star cluster. I'll show you an image of this that I took um, at my my remote observatory in Texas. Let me see a picture that I captured and I processed a little bit. This is with some post processing, but I was able to bring out the blue in this. And look at this. Look at this picture. Look at the nebulosity around these stars. These stars. Now there was a satellite that cut right through. This is probably a Starlink satellite. Thank you, SpaceX. Um, this is a satellite that went right through the image there, and these stars have the main stars have this haze around them, or this nebulosity. This is like dust and gas that was left over from the formation of the star there, and it's just a beautiful, beautiful, haze around the stars. It's actually nebulosity, a lot of dust and hydrogen and some helium are on there. But if you look closely within this star cluster, there are hundreds. And if you look even real close, there's tiny, tiny little stars. There's thousands of stars just in this one view of the Pleiades. And the Pleiades is just one target in the night sky among millions and millions of targets. So it's really very impressive. If you've got any questions, by all means, you can on the chat. You can say hello and ask a question, and I'll try to answer it to the best of my ability. If you're curious about how I'm capturing these images and showing you, this is a live view on your screen of the Seven Sisters. I'm going to zoom in. So just by zooming in, you can start to see some nebulosity around this star, around this star. If I let it sit a little longer, the camera on this cluster, this will become more visible. This haze around the stars will become more, and that's that blue color that I was showing you earlier. This around the stars. This is so now. This is with some editing in I use a program called Graxpert to denoise the images, and another program called Adobe Lightroom to bring out the color. So the color is there. A lot of people say, "Oh my God, you colored it. You artificially colored it." No, it is a blue. Maybe not this exact blue, but this haze and these stars are blue. And what the software allows me to do is to bring out that blue that might normally just look like white, like a cloud, but the blue is there. And with the software, I can bring out these beautiful colors in this in this image. I mean, look at that. That's it's one of my favorite targets. I love that blue color. It's a beautiful, beautiful color there. That's the Pleiades star cluster, and this is the Pleiades star cluster, but this is a raw image from the Seestar. So at the bottom here, you see the little dial. It's taking 10-second exposure. So every time this little dial goes around, that's 10 seconds that went by. That means that 10 seconds that the camera, the shutter of the camera on the Seestar was open, and it was capturing that light, and then it closed. Then it went around again, another 10-second image, then it closed. And then it's stacking those images one on top of each other and layering them to get the definition in the image. And this is the powerful thing about this telescope. It has this stacking feature. So I could take, say, 200 10-second images and tell the software in the Seestar, stack those 200 images and give me, the final result. And it will do that. And then I can further edit it in there. And by the way, the software in here will take out any images that are not clear. It will automatically remove them. So only pick out the best images on there. And I've had the telescope on Pleiades for 4 or 5 hours. I've captured over 1,000 subframes at 10 seconds. And then that's how I arrive at this. This was 5.5 hours. Um, a very, very clear night at the observatory in Texas. I couldn't get type of an image from Miami because of the light pollution. We have light pollution. It's a fact of life. We've got air pollution and we've got pollution in the ocean, but we also have this relatively new phenomenon in humanity since the invention of electricity and the light bulb. We have light pollution. So, what is light pollution? Light pollution is the light from houses, buildings, warehouses, the airport. All those lights that are on, will shoot up into the sky. And if you look from a distance where it's not light polluted, you could look at, like, say, from the Everglades, look at Miami, and you could see the light dome. It's like a white dome and over the city of Miami. That light pollution um, interferes with the ability to capture an image like this. I couldn't get an image like this and process it. This was an image that I was able to get from Texas from the remote observatory. The reason I have a telescope in Texas is because it is a very dark night sky in Texas. It's a Bortle 1. It's very, very dark. Here in Kendall, where I live, and I'm taking this picture right here. This is from my house in West Kendall. This is between a 7 and an 8. The Bortle scale is from 1 to 9. 9 being the most light polluted area, like downtown Miami or Tampa or Jacksonville, wherever there's a lot of light. That would be a 9. Very light polluted. Then as you go down in numbers, it gets slightly dimmer. Here in the suburbs of Kendall, it's between a 7 and an 8. Okay. Not as bad as a 9. Still not great, but enough to be able to capture these images. The further we get west, the number goes down. The observatory that I participate in with Southern Cross Astronomical Society is out on 217th Avenue down in the Redlands, and it's very far west, and it's very dark out there. That's about I believe about a 4 in and the Bortle scale, and that's pretty good. Texas, where my second Seestar telescope is, a Bortle 1. That's one of the darkest areas in all of North America, is right in the middle of Texas. It's near a town called Brady, 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 Texas. It's about 30 miles away from that small town. So the small town doesn't produce a lot of light, and this place is about 35 miles away. It is very dark. It's so dark. I've never been there, but I'm in communication with a lot of people that are there on the ground and the staff there. it's so dark you can't see your hand in front of your face at midnight. If it's a new moon, if it's a full moon, the floodlight in the night sky, you could see it's like a light, and you could see things. So let's see. Haven't been able to get good shots of Saturn. Well, that's a good question, Amara. Right now, Saturn, unfortunately, has left us. It is now very close to the sun. So as soon as the sun sets, it's gone below the horizon. So we unfortunately cannot see Saturn again until I want to say maybe August, September, it'll move around and then start to reappear in the east, as it gets dark, in maybe 4 or 5 months. But unfortunately, Saturn, I did view Saturn. Saturn is my favorite planet without a doubt. I don't know, it's a toss up between Saturn and Jupiter, but Saturn, I always say I got to get my Saturn fix, because it never gets old. Looking at Saturn is just I I've done it all night. I've had my visual telescope fixed on Saturn for 3 or 4 hours, and I'll look at it, go inside, get something to eat, come back out, look at it again, get some coffee, come back out again, and it never gets old. Seeing those rings on Saturn is breathtaking. It's just phenomenal. So unfortunately, right now we can't see Saturn, but uh, we will soon. I've got some images that I was able to capture of Saturn with my iPhone through the eyepiece of the Celestron, and they're not the best pictures, but it's hard to get the planets. The digital cameras can't do that great with a very bright object against a uh, black background. Here with the Pleiades, the Seestar it does a great job because it's just a round star. There's no features on it. It's just like a little light, but when we're trying to look at Jupiter and seeing the brown bands of Jupiter or the ring of Saturn, that's detail that these digital cameras cannot capture. So hopefully, Saturn will come around again and grace us with its beautiful presence, sooner than later, and definitely. But right now, the star of the night sky, in my opinion, is Jupiter. Right now, Jupiter is just uh, immense. Jupiter is the largest planet in the night sky, and you can see with a pair of binoculars. If you have a pair of binoculars, go outside tonight and look at Jupiter. Right now, if you go outside and look towards the west, a little bit towards the west and up, you will see what looks like a very bright star. That's Jupiter. That is not a star. That is the planet Jupiter. And if you get your binoculars and look at Jupiter and you have a steady hand, you can actually see the moons of Jupiter through a pair of binoculars. I'm not making this up. This is true. You can go outside with a pair of binoculars and look at Jupiter. What I like to do is I like to like rest it against like the corner of the wall of my house, the binocular, so that it doesn't move, because when you're trying to focus that much, just the vibration in your hand makes it a little bit hard to focus. But I like to put the binoculars against something that won't move, either like a pole outside or even a tree. If it gives me a clear view to Jupiter or one of the targets that I'm trying to look at with the binoculars, and it keeps it very steady, you will be able to see the moons, the Galilean moons of Jupiter, with a pair of binoculars. You should try it sometime. It's really amazing. There's a lot of things you could see with binoculars. You don't necessarily have to have a telescope, just a pair of decent binoculars. I've got some binoculars that were like $75. And then I got a really nice pair of binoculars. Those are my wife's, the Celestrons. Those were about $150 for that pair of binoculars. And wow, amazing. But yeah, so Saturn, let's see. I used to have an old Tasco. Yeah. Tasco. Oh, wow. They used to be based here in Miami. If you remember, off the Palmetto Expressway in Northwest 25th Street, that big building, I think now it says Aerosail or something like that. That was the Tasco um, building. And I have a friend of mine, that's an interesting story, a friend of mine whose family um, was where the founders of Tasco, and that became a very large company, and it was based here out of Miami. They sold telescopes, binoculars. I think they even sold like camera lenses and things like that. And Tasco, that's a name I haven't heard in a while. 800 millimeter that I used to see Saturn's rings with. Yeah, was tiny, but it could still see them. Yes, Saturn is not a very big target, and right now it's pretty far away. I'll have to look up when it's going to look bigger and be, closer to Earth. It will appear larger in the telescopes, but it is pretty small right now. But when you look at it, you can increase the magnitude of the eyepiece and get a little bit better view on it. It's something spectacular. Now, one thing interesting about Saturn right now is the rings of Saturn, and they normally are usually at an angle, at a tilt, so you could see the lines in the ring. Right now, in the last year, the angle has been straightening out. So right now, it's almost edge on, which means that if you were able to see Saturn right now, it looks like a line. Like, imagine you're looking at a sheet of paper right the very edge, and you're looking straight at that edge, and it just looks like a line across the planet Saturn. So that's something that is really something amazing to look at. It still looks beautiful. I like it when it's at a tilt, and you could see that gap between the ring and the planet. That's beautiful. So here we are, and I think that, let me see, is it dark in Texas? Let's go to Texas for a second and see what's going on in Texas over here. Okay, let's get out of there. All right, we'll go there, and then we're going to go to Starfront and see what the status uh, of the observatory is tonight. It should be clear. I looked at the weather. We should have clear skies. This is the website for. Look at all those telescopes there. This is like a video they have there. There's over 250 telescopes at this place. This is an amazing place. I'm so happy to be there. One of my scopes are in there. Look at these. This is a drone footage there of the buildings. That's showing six, but they're actually up to 8 buildings now. They have capacity, I think, for slightly over 300 telescopes there with the buildings that they have. Let's scroll down and go to the status page and see where we at with the. Okay, we've got this is a sky view, all sky camera that's looking straight up at the sky. It's a little cloudy. The roofs are still closed right now, so this is a live view of the in building 1. Here's a live view of building 2. The roofs, you can see the telescopes there. The roofs are closed. So I'm hoping, let's see what the weather is looking like down. Oh, there's some cloud action coming over Texas. I thought it was going to be clear tonight, but it's, yeah, clear sky report is showing that it's going to be clear. The seeing is not going to be that great, but it's, cloud cover, it's supposed to be clear. So I don't know, why that is, as it was wrong, but we'll wait. Hopefully that will clear up. And meanwhile, we're looking at the Seven Sisters Pleiades star cluster. Now, let's go to a different target. We've been on M45 for a little while. It's a beautiful target. And it finished capturing it's got this little part up here in the top right that didn't finish capturing this little, maybe I'll let it sit there and finish that part of the panel there. But we're going to go to another target in the night sky. We're going to go to M1, the Crab Nebula. Okay, one of my favorite nebulas, just because of the history and the story behind this nebula that we're gonna see. This is a nebula that was what was left over after a supernova explosion that was first documented by Chinese astronomers in, I believe, 1054. In 1054, the Chinese people, these Chinese astronomers, noticed that in the night sky, a star had become very, very bright, and the next night was brighter, and the next night brighter, and it became so bright that it cast a shadow like the full moon in the night sky, and it was not the moon. And it got so bright that it could be seen during the daytime. That's how bright this thing got. It lasted, I think, for, I don't know, just under 30 days. Then it disappeared. That was one of the very first documented supernova explosions ever in the history of mankind. And what is left over, what we're going to look at, is the Crab Nebula. This is a beautiful nebula that is a bunch of dust and gas that is left over from that supernova explosion, almost 1,000 years ago. So let's see. We'll stop imaging the Pleiades. Thank you very much. And now we're going to jump over to M1, the Crab Nebula. Okay, so we're gonna go over here and we're gonna go to the Sky Atlas. There's the Seven Sisters. We're gonna go look up M1. I'm gonna look it up right here. There it is, right? The Crab Nebula. So this is what it looks like. It's like a this beautiful haze of nebulosity and dust. Uh, I've got some pictures of this, and you can actually see like veins around the edges. They're like bluish green veins. Just beautiful. It's in the western sky. It's pretty high right now. It's at about 60 degrees above, 62 degrees above 66 degrees, I'm sorry, the current altitude right here. I'll zoom in there. This tells us everything. It says the Crab Nebula is a supernova remnant and pulsar wind nebula in the constellation of Taurus. And let's see, the person that discovered this, let's see, the nebula was discovered by English astronomer John Bevis in 1731. And it corresponds with a bright supernova recorded by Chinese astronomers in 1054. I knew it was 1054. The nebula was the first astronomical object identified that corresponds with a historical supernova explosion. So I love the history. I've read a lot about this. This is just a beautiful thing. So I'm going to tell it to locate this on the Sky Atlas, and there it is. I'm going to go in and I'm going to tell it to start imaging this. Now, this is a little fainter than the Pleiades. It's going to take a little bit longer. See, but there's in the constellation of Taurus. There's the horns of Taurus the bull. It's right on the tip of one of the horns there, and we should start to get an image of it pretty quick. There's the blue box that's going over the target. The Seestar right now is really kind of hyper focusing on this target, and it's moving and calibrating to get the right alignment for this target. Now, here we go. The first 10-second exposure is not going to really yield a lot, but you might. I'm going to turn off my light here so I can see the screen a little bit better here. So you might see like a little fuzzy right in the middle of the screen. I don't know if you could see that. There's like a little tiny haze right where my mouse is, right there. There's a little cloud right there. That is the Crab Nebula M1. Now, it's now working on the third 10-second exposure. As it takes more 10-second images, it will become brighter, and you'll start to see some more definition in it. As this is imaging, I'll tell you, people ask me, Carlos, what's up with the M? Um, why M this and M45 and M31? M stands for Messier. Charles Messier. Charles Messier was an astronomer. He actually was a comet hunter in the 1700s, in the early to mid 1700s, and he was obsessed with looking for comets in the night sky, as there still are today. A lot of people looking for comets in the night sky, and a lot of the comets that are discovered by amateur astronomers, even to this day. Well, Charles Messier went out with his telescope and started looking for comets, just randomly scouring the night sky, and then he could come across something that looked like this, like a little cloud, and goes, "Oh my God, I found a comet! It's a comet!" And then he would look at it and then write the position down where it was. The next night he'd come back to it, and then he'd look at it and go, "Well, it doesn't have a tail on it, and it doesn't seem to be moving." And then a week later, no, it hasn't moved. I don't know what that thing is, but that's not a comet. And he would be very upset that it wasn't a comet. So he would write it down on a piece of paper. He goes, this target here that I thought was a comet is not a comet. It's located in this constellation of Taurus. Avoid this area. Don't get confused and waste time on it in the future. And then he kept working, and then he kept coming across all these things in the night sky. These fuzzies, he would call them fuzzies, like, oh, these clouds, and sometimes they look like little stars, and he would write them down in a book. Little did he know what he was doing was creating a catalog of uh, targets in the night sky, deep space objects, DSOs, like the Crab Nebula, like M45 and things like that. So over the course of time, people would come to him saying, these things are very interesting that you're writing down, you're finding in the night sky, though they're not comets and you're not too happy about that. They are very interesting. And we're going to study these things and keep making that list. And then he started, realizing that other astronomers were discovering different things. So he would go to them when they would discover something. And he would ask, I'm putting it together like a list of targets, and would like to ask if it would be okay, since you discovered that target, if we could add it to this list. Oh yeah, by all means. So he gives credit to a lot of other astronomers that found different targets, but this this may have been observed by other people in the night sky. Very difficult to see this. You cannot see this in the night sky with a pair of binoculars. You cannot see this naked eye. You really do need a telescope of some sort to even see a little, a little haze of this thing. This is very small in the night sky, but the Seestar is doing a pretty good job right here. Look at that. I'm going to zoom in a little bit. You see that little cloud there? That is the Crab Nebula that's coming into view there in the constellation of Taurus. As we saw earlier, it's in one of the horns of the bull Taurus. And this will get clearer and clearer as I let it sit there. Right now, it's at about 3 minutes and 20 seconds worth of exposure there. So let's see if anything's happening at Starfront. Okay, they opened the roofs. All right. Okay, folks. The roofs are open. The roofs rolled back. And I'm in building 6. And here's my building. I'm actually in the very, very front. You can't see my telescope. It's in the front and the top here. But this is an amazing place. They automatically they have motors that move these roofs on rails. They move them back and open up the the buildings and expose the telescopes that are there. So it's still daylight over there. It's getting dark. The sun is setting. This is out in the middle of like the desert in Texas, very, very remote. And this is the observatory there. And they have 8 buildings right now, of which 5 are occupied. Almost 6, actually, no, 6 are occupied. And there's telescopes in them. And each one of these telescopes, like my telescope, is uh, is owned by an individual or a school, a university, a research institute. There's even a couple scopes here from NASA at the observatory. They do research with some of the telescopes, and they can log into their telescopes like I do remotely. There's people from Japan, people from Tokyo, people from Paris, France, from Berlin, from Canada, from every corner of the world that have sent their telescopes to Texas to be in this phenomenal place, the Starfront Remote Observatory. So now we're just waiting for it to get a little bit darker. And if I was to wake up my telescope right now, we'd see a lot of light right now. So we'll wait a little bit more. Let's go back to the Crab Nebula. There it is now. More definition on the Crab Nebula. Can you see it? It is right there. Right there. Zoom in a little bit. Now we're starting to see a little bit of like reddish pink in this area right here. And you will start to see some veins around this. So this was like the Chinese documented in 1054, an explosion of a star. Stars, when they die, uh, they run out of fuel. Their main fuel source for most stars, including our sun, is hydrogen. Hydrogen and helium, principally hydrogen. It is the fuel of a star. So when a star runs out of its main fuel source, being hydrogen, what happens? It starts to shrink and it starts to get dimmer, which is what is happening now with Betelgeuse, the star in Orion, which is the shoulder or the armpit of the Orion constellation, Betelgeuse. It's not just a movie; it's a real star. It's called Betelgeuse, and that star is fluctuating in light. Scientists have been looking at this now for the last couple of years. It's getting dimmer, then brighter, and then it gets real bright, then it gets real dim, and then scientists believe that it is right now in the death throes. That it will soon run out of hydrogen and start to compress and collapse upon itself. What a star does when it dies, runs out of hydrogen, it starts to compress upon itself and get smaller, and then the mass becomes so much that it it just crushing. It's like getting a like squeezing an 18-wheeler semi into into a go-kart, the size of a go-kart, squeezing it that tight to the point where it cannot be compressed anymore. And at that point, it explodes in a massive supernova explosion, which is some of the most powerful explosions that scientists have ever documented or mankind has ever witnessed. And then that star explodes and dies in a massive supernova explosion. What is left over, the dust, the material, all those rocks, all those things that are left over, become this haze. This is what was left over from that massive explosion. And then from that haze, many times, not all the time, but many times, those components are the right combination of chemicals and hydrogen and helium and metals, then that become the components for the birth of new stars. For example, Orion, the Orion Nebula M42, is a prime example of a star nursery. That was a supernova explosion, much like the Crab Nebula. We don't know. I don't know exactly when that one blew up, but it is now a region in the night sky where new stars are being born from this dust. So, when a star dies, it dies and leaves all the material so that other stars can be born. They'll be born, expand, live their full life. They'll eventually die in a supernova explosion and leave the material there for the birth of new stars, and the cycle of star life starts all over again. But that is what basically happens with these stars. Here you can start to see now, even a little bit more red there on the top part there. Yeah, it's a beautiful beautiful image. I'm gonna see if I could find. I'm gonna look for. Let me see here. I'm gonna look for an image that I have of. Let's actually, I'll try to find that, and I'll try to display that in a little bit here of the Crab Nebula. Let's actually Google it. That's the best thing. So you can see what this thing's going to look like here. So I'm going to go here. M1 Crab Nebula. Okay. This is what it looks like. Here. This is Wikipedia. Image that I have is not as good as this, but you could see all the veins around. This is looks kind of small, but this is a massive, massive thing. This spans I don't know how many light years this spans this across. It's quite big. The Crab Nebula M1 or NGC 1952 is a supernova remnant. We already know that. Has a magnitude of 8.4. That's the brightness of it. So Orion is a 4. This is less than half the brilliance or brightness of Orion, so it's pretty dim, and it really is a spectacular target. So if we let the Seestar sit there for 5 hours, which we're not going to do, it would come close to this on there. So this is probably an image that either the Hubble telescope took or James Webb took. Let's see, Joe. Betelgeuse may have already gone supernova. The light that just hasn't reached us yet. You're absolutely right, Joe, and thank you for joining us. You are absolutely correct. Because of the vast distances of these stars, as Joe just mentioned in the chat, Betelgeuse could have already exploded in a supernova explosion. Since it's 650 light years away from us, it will take 650 years for the light of that explosion to reach us or reach our eyes so that we can see it. So that thing may have 300 years ago, may have already exploded in a supernova explosion. The light, it's so far away, it takes that much time for it to reach us here on Earth. So we don't know. Scientists can't tell by looking at it if it's already gone, because when you look at it, what we're looking at is light that took 650 years to come in through the tube of a telescope, hit the mirror in the diagonal, and then go through the eyepiece and into our eye and into our retina. So that is, it takes a long time for this light to travel because these distances are so far. But you're absolutely right, Joe. Yeah, but Thank you, MR. Thanks for the info. Yeah, you're welcome. And yeah, Starfront, check it out. It's an amazing place. Speaking of which, let's try to go back there and see. Yeah, the roofs are still open. It looks like it's pretty bright. Let's look at that all sky camera at the top there. There's a little bit of clouds there, but we're gonna see if we can wait a little bit longer. Right now it's 9, so it's, let me look and see when is the sunset there in Brady, Texas. Oh, it's saying the sun is already set, so just a little bit more, probably like 10 or 15 more minutes till we get darkness there, but we'll stay on M1, the Crab Nebula. Look at that. Now starting to get some more color, a little reddish right in there. And it's just sitting there. The camera of the Seestar is just sitting there, focused from my patio here in Kendall on the Crab Nebula M1. Yeah, so pretty cool. And yeah, if you haven't already, you can follow me on Instagram at Star Pictures Miami. I post pictures on there. I also have a lot of videos coming online on the YouTube channel at Star Pictures Miami, and the website starpicturesmiami.com, where I today posted my explanation and images from the capture of the total lunar eclipse on early Friday morning. Check that out. I've got some great pictures on there, and I just haven't had the time to sit there and process all the images. I'm gonna turn on the light again right now, and then we get this cable over here, and we're gonna plug in the laptop. I didn't realize it was so low on there. We're gonna, oops, plug that right in there. There. Now we're charged up. So yeah, that's going to the website there, and there's a website. Here's the post I would just put up this morning. I've got so many pictures in so little time. I mean, I end up with, two telescopes imaging almost every night. That's hundreds of pictures that I have. But there's the eclipse. That's when it was blood red, right there. And here's some of these pictures. We like these pictures because they're like, to me, it looks like they're glass, like this image of the moon being, red, even though it looks orange. It looks like a glass moon to me, like a kind of a semi-transparent glass moon. But yeah, that's the post on the eclipse there, and then we'll go back there to M1 and look at that. Now we're starting to see some of the veins in here. See these little lines right there? I'm putting the mouse right on there. Starting to see these little veins right there. And actually, I can apply on the images as it's developing some AI noise reduction. And I'll watch this. Hit the little wand here, and it's going to clean that up. No, I haven't heard anything uh, about that star of Borealis. That is something that's, a lot of people have been talking about that one as well. Possibly going supernova on that one. But going back to the M1, so you see the how it cleaned it up. For comparison, that's the cleaned up image. That's before, after, before, after. So before, you could see this little haze around the image, that noise that has come on because of the light pollution here in Kendall, and with the AI, it cleaned it up a little bit, and that's just with 15 seconds of denoising the image on there. But you could start to see that it's starting to come through. I can change the color balance here of the image, make it darker. I can brighten up the hues of the color there. Look at that. Look at that. You can start to see as I start to enhance it a little bit. This is just basic enhancements on the Seestar that, with the contrast and the color balance, we can start to see some of the veins in this image of the Crab Nebula M1. It's a beautiful target. It's not very large, but it is very interesting. If anybody's got any questions or anything like that, but you can post them on the chat. And let's see what we've got. That's M1 there. I'm eager to get on something here in Texas. Let's see. So where are we here with Texas? Status. Come on, Texas. Let's update here. Okay, there's some clouds up there, man, but okay, it's getting darker. Okay. I think we can open up Texas here. Let's okay, here's the dashboard of the Seestar in Texas. Let's make sure we're level. We're going to go here to calibrate, adjust level. Yeah, 0.2. That's pretty close, man. That's almost right on the money. That's close enough for jazz. They say anything but 0.3 or lower, below is perfectly acceptable. So I'll go with that. And then we'll go over here and let us look at something that's going to resolve very quickly here. This is like no line, no waiting. The famous M42 Orion Nebula here. So this is, let me actually pull it up in the Sky Atlas. We don't want to do that. We want to go here, Sky Atlas, and then we're going to go look for M42. M42. 42 Orion Nebula. So we'll tell it to look it up in the Sky Atlas, and boom, there it is. This is just it's a huge target, massive. I'm going to widen this a little bit so you can get an idea of this. So there's so much here. It's mind-boggling. This nebula is very large. There are many things in here, many stars, many targets. Famously, like the Flame Nebula, the Horsehead Nebula is in here. We've got M43, which is another area of Orion. We've got these big HD stars, HD 36960, NGC 1980 in there, and there's just so much. So rather than talking about it, I'm going to just tell it to go to this, and it's dark enough, and we'll come in. The red dot is where the target is, and we should be seeing a blue. Here comes. This blue box is the lens of the Seestar moving to where the Orion Nebula is. This is the Seestar in Texas at Starfront. So there we are now on M42. It's doing its calibrations since it's the first image right there. It's refining what it's looking at. It's like hyper focusing. It's doing some horizontal calibrations. It's taking some darks and adjusting the sensor, prepping the sensor for the image capture. Okay, there it is. It's A little blue box represents very, very minute movements in the lens of the Seestar to really hyper focus on this target that I have selected with a red box. That says moving to first calibration point. Seestar is performing horizontal calibration to correct placement errors. This process takes about 2 minutes. So it's going to do this for a couple minutes. And then while it's doing that, we'll go back to, let's see here. We'll go back to the Seestar in Miami, and there's a Crab Nebula. Let's see here. So we're going to go, I'm going to reset it back to, without this. Let's see, let's go back. Okay, that's the raw image right now from the Seestar here in Kendall. M1, the Crab Nebula. But even in this raw haze, you could see the veins are starting to come through. It has like this spine in the middle, and then these kind of like veins that reach out. You know, I always like looked at that like a spine there. But yeah, it doesn't look like a crab. You know, a lot of these things, I mean, they come up, whoever named these things, I mean, they named this the Crab Nebula. Somehow they thought it resembled something like a crab. The horse head looks like the head of a horse. You know, the Monkey Head Nebula, you could see two eyes and you could see the ears, and it looks like a monkey. You know, but this doesn't look like a crab at all. But here we are. It's the Crab Nebula. It's a beautiful target, and we should get some really cool images of it. But wait till you see Orion. Orion M42 is going to blow your socks off. And we're going to go back. Pretty dark in Texas. Pretty dark. All right. Can you level Seestar remotely? Yes. It has a cool feature that they did in about like 3 firmware updates ago, 4 firmware updates, where if it's in the general ballpark, you can artificially level the sensor in the Seestar. So you don't physically have to touch it and adjust the legs to get it just, you know, within that 0.3 range. You can actually adjust it by doing a calibration on the sensor, and it'll get it to like 0.1, 0.2, which is acceptable for the Seestar. So let's go back to Texas and see what's going on over here. Okay, here comes Orion. As I mentioned to you, it's very bright, resolves right away. Thank you for joining us, you know, tonight and joining me here on this online star party brought to you by Star Pictures Miami. My name is Carlos Garcia. I'm a local astronomer in the Miami area and member of Southern Cross Astronomical Society. It's an astronomy club, one of the second oldest astronomy organization in the United States, founded here in South Florida in 1922. So has a very rich history here in South Florida. A lot of people have heard of Southern Cross. So here's Orion. It is coming in view right now. There it is. This is this is the first 10-second exposure. One 10-second exposure, and look at this. Very bright. It's still getting its bearings there. It's moving around a little bit. The Seestar's moving around, unless there could be some wind over there. Let me check. Is there wind in tonight in Texas? Let us see. What's the wind? Oh, it's not showing any wind. Showing clear sky. Let's go to Astrospheric and look at Texas. It's on my favorites list. At Starfront, no, wind is, well, 16 miles an hour. That's pretty strong. So there might be a little vibration there with the wind. The guiding, what they say is the guiding is off because it might be moving around in the wind. Yeah, when they open up the roofs now, those telescopes, including mine, is standing up, even though there's some walls that are about maybe 3.5 feet high, and they're blocking some of the wind. They're not blocking all the wind, and so we might get a little shakiness in the image there. But that's Orion M42, and probably the most photographed target in the night sky by far. It is. Everybody images Orion, and that's an easy target to find. It's an easy target to look at. You can even see this in a visual telescope, not like this with that color, but it does show up like a haze. You can definitely see the cloud in there. It's very, very beautiful. So that's M42. We've got um, two telescopes going at the same time here. There's Miami with the Crab Nebula. And then we've got Orion Nebula right there in Texas. So it could be a little on the windy side. Let's see if we could see what's going on with the wind here. These are live images from Starfront. These are cameras that are mounted at in the front of every building. There's 8 buildings right now. Here's a weather forecast. There is some cloud there. Starfront is right around here where I'm pointing the mouse, right in the middle of Texas, right there. There's some clouds overhead. So the seeing conditions are probably not going to be that great. But even though it says on Clear Sky Report that it's supposed to be clear now, it's not. So that's what we got. We got that. So M1, there you go, M1. That's the Crab Nebula right there. I'm going to move this now. Let's move on to something else. Let's move on to one open star cluster before we call it a night. Let's go one of my favorite star clusters, M47. M47 is an open star cluster. And we can go over here, and we're going to go there. M47. Okay. Beautiful star cluster, especially in a visual telescope. This is just a gorgeous view. These stars are very bright, and there's a double star in here, and there's a couple stars like this one over here that's like a orangish red. It really does show up orange in a visual telescope. So right now it's at 49 degrees to the south. Okay, let's locate this on there, and there it is. So I'm going to tell it to go right to there. This one will resolve quickly because it's a group of stars. Stars are bright. These stars are brighter than average in this cluster. That's what I like about it. It's very easy to see in a visual telescope. So this is the telescope in Miami, and it's not too far from Canis Major, which is the hunting dog of Orion. And there it is. It's focusing on it now. We should get that resolution here in just a moment. The open star cluster M47. And we should get an image here, and here we go. First 10-second image should show the group of stars. This is the Seestar in Miami here in Kendall right now. Let's see what we've got. Okay, there's the first image right there. Yep, that's coming along nicely there. Okay, the camera just moved a little bit. So this star cluster is an open star cluster. There are many of these. You know, ooh, look at that. That was some satellites that just went through the view of M47. Wow. Thank you, SpaceX. Thank you, Elon Musk. Or that could have been an airplane. But look at that. Look like three lasers cutting across there. I'll have to get that frame out of the stack. But this is a problem. This is a you just saw it, folks. I mean, that is an every night occurrence that was not anything that was happening 30, 40, 50 years ago. Is a relatively new phenomenon now with SpaceX twice a week launching rockets with Starlink satellites, low orbit satellites. We have now satellite pollution. We've got light pollution here on Earth and up in low Earth orbit, satellite pollution, polluting our images. That's the reality of it. You just saw it. That's amazing. That's actually happened to me while one night I was looking at Mars about a year ago, and three times that I looked at it, a satellite just zipped right across the view, and it looks very cool. You can see it. It moves pretty quick, but you can definitely see that it goes in a perfectly straight line, and three times in the course of about 15 minutes, I saw three satellites moving in front of Mars. Cool, but then after a while it gets old and it just starts to really butcher these images. And that's something that I really, struggle with, because now that I have to go in there and remove those frames and look for the frame that had the line coming through it and remove it if the software didn't find it, stuff like that. I know these are high class problems. I understand these are definitely first world problems. Oh, some satellites went across my image. Oh, poor me. But yeah, that's the reality of it. But this is M47. This is a beautiful star cluster that I am, always looking at in the night sky. This one in M46. I learned the other night from one of our members from Southern Cross, Pat, was telling me that there is a planetary nebula in M46. I think it's the blue snowball, and lo and behold, we were on a session and with the Seestar, it says, Carlos, pointed at M46, point the Seestar at M46 from Texas. And we did, and boom, I couldn't see this in a visual telescope. On the Seestar, it's the first time I saw it. Yeah, there is a little round fuzzy that if I let it sit there for about an hour, it does turn blue. That it looks like a little round cloud, perfectly round cloud. That is the blue snowball. It's called the blue snowball in M46. M46, M47 are not too far from each other. But yeah, there we go. Open star cluster. Well, and that's Orion right there. So, well, thank you very much, everybody. It's a little bit past the closing hour here at Star Pictures Miami. Thank you very much for attending, and check out our website, starpicturesmiami.com, and the Instagram for updates on future star parties. Thank you very much, and clear skies. Good night, folks.